Hello everybody, hope you're doing well and thanks for joining us for another video. Now I typically publish my videos on a Wednesday, and this particular Wednesday just so happens to be Christmas Eve. So, season's greetings to everybody watching. And today also marks 57 years since the crew of Apollo 8 did their quite famous Christmas Eve TV broadcast from lunar orbit, where they read from the book of Genesis after becoming the first humans to travel beyond low Earth orbit.
In the beginning, God created the heaven and the earth.
Well, unless you're of the opinion that the moon landings didn't happen, in which case you'll probably say that it's 57 years since people first faked travelling beyond low Earth orbit. Now, it'll come as no surprise that I get many comments from people arguing that no humans have made it to the moon. But within those comments, I've had a few similar arguments of people putting forward something along the lines of saying, if NASA landed on the moon back in 1969, then we'd have X, Y, Z on the moon by now. For example, I've had people argue that the military would want a base on the moon as it would make a great strategic advantage for launching missiles at other countries or spying on them. And some have asked, why haven't NASA set up a live stream feed or a telescope on the moon aimed at Earth? So, as it's Christmas, I thought I'd go through these ideas and why they're pretty impractical. Firstly, from a military perspective, you might think an outpost on the moon offers some sort of strategic advantage over other countries, but in reality it doesn't. For starters, the idea of using it for launching missiles, well, the moon is around 250,000 miles from Earth. It takes a spacecraft about 3 days to travel between them. Even if you say an ICBM could fly faster coming back to Earth because it had more fuel when it launched from the moon, you're still realistically looking at 2 days, perhaps. Certainly more than 1 full day of flight time from the missile launching to it reaching Earth, which would give plenty of time for any target country to react and intercept it, versus launching an ICBM on Earth, which will reach a target in less than 30 minutes, giving very little warning. Not to mention, you also need to get such missiles to the moon in the first place, which would either need an incredibly large rocket or many separate rockets ferrying up all the parts and building them on the moon. Well, rather than having all those rockets and the fuel ferry ICBMs to the moon, you might as well just put warheads on them and launch those from Earth instead. Now, some have suggested that colonizing the moon would be a strategic advantage in case something happened on Earth. Jaren, I think, actually put that idea forward during one of our discussions about the moon landings.
I still think that there really is no good excuse for not going back, other than if you say, well, there's no reason to, but then you're like, well, wouldn't there be a strategic position there? I would think that whoever the country is that's there kind of owns the world in a way. Also, I think, let's say that we believe everything that NASA says. So there's meteoroids, there's asteroids flying around. So the human race could literally end at any time. And so having somebody on the moon would preserve that. Not having anybody on the moon could be the end of the human race because NASA is inept, which is kind of ridiculous. Like we are at this point, if we have the capability to put people on the moon, there should be a permanent presence on the moon, which would just protect humanity from extinction.
The problem with this, though, is the moon doesn't have any natural resources needed to sustain life. Bases on the moon would likely be very reliant on resupplies brought from Earth. But if you then remove life on Earth from the equation, suddenly that backup support's gone. Arguably, it's possible, provided you have systems that can grow food, whilst being able to recycle 100% of the water and have an endless power supply. Nuclear would be an obvious suggestion for that, but reactors have a limited lifespan, so they'd be worn out within a generation or two. Solar could be a better option, but this ties us into the problem of the idea of putting a webcam on the moon viewing the Earth, which is something people have argued that NASA would have done if they could get to the moon. So let's just consider such a setup. You would obviously need a camera, but depending on the camera setup, you have other potential problems. Because whilst the moon is tidally locked to Earth, it goes through libration over a 28-day period, which is the apparent wobble. So from the moon, whilst the Earth would stay in roughly the same region of the sky, it would still move around quite a lot. So you would either need a wide view camera to allow room in the frame for the Earth to move, or you would need a motorized mount to keep the Earth centered. But then such a mount would also require power as well. That is before you factor in that these people are suggesting a live stream, which means the camera feed would need to be transmitted back to Earth in real time, which then requires yet more power. Now sure, they had such a setup on the lunar rover during Apollo, a camera on a motorized mount with a live transmission back to Earth. But that thing only had sufficient battery power to run for about one full day. If you remove the driving elements from the equation, you might be able to run the camera for 2 or 3 days before the battery dies. But NASA are not going to spend millions on a rocket with the sole purpose of launching a webcam to the moon to view the Earth for 3 days. If there was going to be a live stream feed of Earth, it would need to be continuous. Now, you could have solar panels to get power. The problem is, with the moon being tidally locked to Earth, it rotates once per orbit, so once every 28 days, meaning any spot you place the camera would be in sunlight for 14 days, so you could run that on solar for that period, but then it would have 14 days of darkness, meaning the camera would either only be running half the time, or you would need a bank of batteries sufficiently large to run the camera, any mounts, and the transmission feed non-stop for more than 330 consecutive hours. But then it's not just a case of batteries overnight and solar during the day, because you'd need sufficient solar power to not only run the equipment, but also simultaneously recharge all of those batteries back up fully. That would be a monster setup to get in place. Sure, not impossible, but substantial. And the big question, why? Why would NASA spend all that money to set up a live stream feed of the Earth from the moon? Bearing in mind, it seems this suggestion usually comes from flat earthers, as though they think NASA should create this live feed setup to prove the Earth is a globe. They're never going to do that, at least for that reason, because there's no benefit to them. NASA don't need to check if the Earth is a globe. NASA don't really care if a small portion of the population think the Earth isn't a globe. And even if they did care, they aren't going to spend all that money on a live stream from the moon to prove it, because they know those people who don't believe them still won't believe them even if they do it. NASA already have live streams showing the globe from the ISS. Those same people dismiss that as fake, so they'll undoubtedly dismiss a stream from the moon as well. In fact, there's no doubt about it because they already do. As already covered, NASA had a live feed of the Earth from the moon during Apollo broadcasts using the rover camera. That gets dismissed. And this footage of Earth from Apollo also highlights the problem with the idea of using telescopes on the moon to view the Earth. Some have suggested that an observatory on the moon could be built, with there seemingly being a mixture of suggestions. Some saying a telescope to view the Earth, either for scientific or military purposes, and others, I think, suggesting a large telescope could be built on the moon to view deep space because there's no atmosphere to contend with like here on Earth. So, firstly, the idea of a moon telescope to view the Earth, from a military perspective, would be utterly pointless. The point of any such camera for the military would be to spy on enemy positions, see what enemies are up to on Earth. Well, for this, you need a high amount of detail, i.e. being able to clearly see vehicles and even people. While seeing objects that size on the Earth from the moon is just the flip of trying to see objects that small on the moon from the Earth. And plenty of people ask why you can't see the Apollo hardware on the moon with Earth-based telescopes, and the answer is simply that telescopes don't have the resolving power to see a 5-meter wide object from that far away. The Apollo hardware on the moon can be seen by probes, but they're in lunar orbit, only about 100 kilometers in altitude. So spy telescopes on the moon wouldn't be able to get close to the resolving power that spy satellites in low Earth orbit can achieve. The other problem with this idea is the limiting viewing windows it offers. For example, if the US wanted to spy on what was going on in Russia, having multiple spy satellites in low Earth orbit and on different orbit periods would mean that they can have a satellite over a particular area in a very short period of time. However, for a telescope on the moon, it could only make observations when the moon is over that area of Russia, which, depending on the time of year, the moon is visible at times for more than half a day, but other times it's only visible for an hour or two, or even at some latitudes, depending on where the target is, the moon might not be visible for several days, or only at very shallow angles to the target rather than high overhead. So that is completely impractical for military purposes. But what about just generally observing Earth? Well, it's sort of a similar story. I mean, you could say an observatory on the moon would see enough detail of the Earth to track weather patterns and such. However, there were weather satellites in low Earth orbit from the start of the 1960s, well before anybody made it to the moon. And within 5 years of the end of the Apollo program, there were weather satellites in geostationary orbit, which is 10 times closer than the moon. And unlike a moon weather station, which would have a slowly drifting view of Earth, geostationary orbits remain in a fixed location relative to Earth. So 4 or 5 weather satellites at various points of Earth, and you basically have a constant 360-degree view of Earth's weather. But what about not viewing Earth? What about a large observatory to view deep space, because there's no atmosphere on the moon like there is on Earth? Now, the lack of atmosphere would be a benefit. However, there are a few potentially big hurdles with this idea. Firstly, optical telescopes on Earth are only effective viewing the stars in the middle of the night, and most effectively when there's no moon, because any stray moonlight would be able to enter the telescope and will wash out the details of the stars. And given that the moon is tidally locked to Earth, so the same part of the moon is always looking towards the Earth, if you built an observatory on the side of the moon nearest Earth, then the Earth would always be in the sky, which will severely limit where the telescope can aim without getting Earthshine affecting the images. A telescope on the far side of the moon would overcome this problem because it would always be facing away from the Earth, though the issue then becomes how do you get the images from the observatory back to the Earth? It would require either a series of relays like ground-based towers or satellites, or a very long cable to run the data around to the near side of the moon to then be transmitted back to Earth. All a lot of hassle in comparison to something like the Hubble or the James Webb Space Telescopes, which also avoid the problems of Earth's atmosphere, but that can easily transmit data back to Earth by themselves. Sure, such large observatories do typically have larger mirrors than, say, James Webb, so would be able to capture more light, and such a large mirror telescope on the moon would give you better results. But then you'd have to get that giant mirror to the moon in the first place, along with all the other components needed to build an observatory. So if you're going to ferry all the parts of a giant telescope into space anyway, you might as well save the journey to the moon and just build a telescope in orbit. Pretty much all these ideas can be done just as effectively from orbit rather than going to the moon, and can be done cheaper as well, because it doesn't require traveling as far as the moon, nor requiring teams of people going to the moon to build everything up. It's much like why countries have focused on sending probes and landers to the moon rather than people, because landers are able to perform many of the tasks that humans can, but without the need of space or life support that humans require, and they can remain operating on the moon for much longer periods without needing to rest either. Anyway, that's going to be it for this video. As always, feel free to leave your thoughts in the comments down below. If you enjoyed this video and you haven't already done so, then please do consider hitting the like and subscribe buttons. I hope you all have a great festive period, and hopefully we'll see you in the next video.